In one of the previous videos, we had seen that only an external unbalanced force can cause acceleration on a body or in a system. So, for example, so we had taken the example of this system in which me and the chair combined formed the system, and therefore any forces that I apply, or the obviously the chair cannot apply forces, but any forces that are generated inside the system, which could be a push by me on the arms of the chair, or on the chair, or on the system actually, will not accelerate the object, and only an external force, for example if my mother comes and pushes me from this side, or if she pulls me from that side, only then can, so that is an external force, so only then can I be accelerated. So one of you had given me a suggestion. Why not simply apply your brain and push yourself like this? Simple. So you are sitting on the chair, you're part of the system, and yet your force can cause some motion here, some acceleration. So I could pull myself or I could push myself. So yeah, that is a very good question from whoever pointed that out. I believe Harshit. So the very simple answer to that is, in that case, Newton's third law comes into action, and even in that case, um, the force that actually accelerates me is not an internal force but an external force. Now that might confuse you. So let me explain. Actually, Newton's third law is almost everywhere. So everywhere where there's application of force, Newton's third law is there. So in this case, when I push on this arm, I'm pushing, so there's an internal force pushing that is acting on the system, and that force is being generated from within the system. In this case, it is being generated by me. So when I apply this force, I'm applying a force in that direction on the chair, right? So I'm applying a force on in that direction on the chair. But remember, Newton's third law says that for every action force, this force in that direction, there's an equal and opposite reaction force, and that reaction force is applied by the second object on the first object. So in this case, the first object is me or my hands, which are applying some force on the arm of the chair in that direction. By Newton's third law, the chair's arm applies an equal and opposite, which means in this direction, a force which is opposite and equal in magnitude in that direction, that therefore on the first object, which is me. So I am pushing the chair in that direction and the chair is pushing me in that direction, and that seems so it is easy to see why there is no motion, because those two motions, so after all, this chair, the arm, and my hands are part of the same system, right? And we are, so this chair is pushing my hands and my hands are pushing the chair, but we are part of the same system. So we are pushing, it's like fighting with your own self. I am pushing the chair is pushing me, but we cannot move in opposite directions because we are part of the same system. So it is kind of like pulling yourself this way. Will I be able to lift myself if I pull myself this way? Obviously no, it seems stupid. Why? Because from one hand I am pulling myself, but from the same hand but from the other hand I am pulling myself down. So I mean, it seems foolish to do this, because I am cancelling the forces, because the two forces are acting on, well, me, and they are in the opposite directions and they are acting on me. Why doesn't that happen in everywhere, in every situation? Why doesn't every equal and opposite force cancel, and why don't we get any motion? Well, because in those other cases we have two different objects that are applying two different forces on each other. So let me give you an example. In the case when I push myself on the floor by applying a force on the floor, I'm actually applying a force on the earth, or on the ground. I'm applying a force in that direction on the ground while I'm pushing myself, right? And by Newton's third law, the earth, or the floor in this case, is pushing me or the chair, the whole system, with an equal and opposite force in that direction. So now I am applying a force on the earth in that direction, so I am pushing the earth in that direction. So the earth will move in that direction, I mean the floor will move in that direction relative to me, and the earth will apply an equal and opposite force on me in that direction, and that is why I move in that direction. Although I am pushing in that direction, I move in that direction. So that's why how I move. But if I apply something, a force on this direction, here both the action and the reaction forces are acting on the same object or on the same system, me and the chair as a combined system, and therefore the two cancel, and we get a net zero force, net zero external force, and therefore we have no acceleration. So that is basically how Newton's third law and Newton's first law are related. So Newton's first law says that only an external force can cause motion or acceleration, and Newton's third law then gives a justification for the same, because, well, both the forces are in internal forces, the force acts on the same system, and therefore it cancels out. So you may look around yourself, be it riding a cycle or be it anything, whenever you see some motion or some acceleration actually, I can be pretty sure that there is an external force, and if you feel that the force is internal, the internal force must have an external reaction force that is actually bringing that acceleration. So yeah, that is a simple explanation for this. And another example that you had pointed out was that case in which you have a cylinder and a mouse is trying to push it run inside, and obviously the cage then starts rolling, and if you put that on ground it would start moving. Even in that case, when the mouse runs and the cylindrical object is in motion, that cylindrical object actually applies some force on the earth if it is being rolled, and the earth in turn will apply an external force, an external reaction force on the object, and that is what causes motion. So in every case it is an external force that causes motion, and it will never be an internal force. So that is how the Newton's third law justifies Newton's first law. That's it for this video. Bye.